Work and the work energy theorem. As part of the preparation for the stopping distance experiment, you started with the expression v squared is 2 times acceleration times displacement, or change in position. This equation is for starting from rest, an initial velocity of 0. If you then solve for delta x, we get v squared divided by 2a. If I then define delta x2 as the distance it takes to stop when you were traveling twice as fast, it's 2 times v all squared divided by 2a, which is 2v squared over a, which is 4 times the original delta x. So if you're traveling twice as fast, you're going to have to travel 4 times as far to reach that speed at the same acceleration. And conversely, if you're traveling at a certain speed and it takes you a certain distance to slow down, if you're going twice as fast, you're going to need 4 times as much distance to slow down. The same approach works for a non-zero starting velocity. If we start with the same kinematics equation, but this time the full form of it with a non-zero starting velocity, and then do a little algebra, we can show that this relationship is true. You can work that out for yourself on a piece of paper if you can't see where it came from. Starting here, you can get to here. Now what we're going to do is introduce the mass of whatever's moving. If we multiply throughout by m, we end up with m times v squared over 2 minus mv0 squared over 2 is m times a times delta x. If you remember from Newton's second law, the ma is the force that's being applied to cause that acceleration. And so we end up with this equation here: force times distance, or force times displacement, is equal to the change in this quantity mv squared over 2. So force times displacement is the change in 1/2 mv squared. And the quantity on the left, force times distance, is the work done on the object. And this is equal to the change in kinetic energy of the object. 1/2 mv squared is the kinetic energy of an object of mass m moving at speed v. And in order to get something up to speed and impart this amount of kinetic energy to an object, we have to do the work, force times delta x. And that's the work energy theorem, that force times distance is change in kinetic energy. We can write that out in words. Force times distance equals k, which is kinetic energy.